Today, I will be discussing advanced technology vehicles, focusing on hybrid and electric vehicles. Some of the subjects to be discussed in this presentation will be the history of hybrid electric vehicles, different levels and types of hybrid electric vehicles, hybrid vehicle operation of each type, some of the advantages and disadvantages of hybrid vehicles. Then we will switch gears and speak about the history of electric vehicle operation, advantages and disadvantages of electric vehicles. Starting with hybrid electric vehicles, a little bit of history. In 1901, the first hybrid car was developed by Ferdinand Porsche. It was called the Lohner Porsche Mixed Hybrid. The prototypes were front-wheel drive with two hub-mounted motors driven by a battery. And then later versions were four-wheel drive with four hub-mounted electric motors driven by a battery, the battery charged by an electric battery which is charged by a generator driven by an internal combustion engine. In 1997, Toyota came out with the first commercial modern hybrid. It was released in Japan only during that time. In 1999, the Honda Insight was released in Japan and the US, and shortly after that, in 2000, the Prius was launched worldwide. When we talk about hybrids, we have four major levels of hybrids: micro hybrids, mild hybrids, medium hybrids, full hybrids. We will go into details in the next couple of slides. All hybrids feature idle stop function, regenerative braking. The idle stop function is a neat function because it shuts off the engine during decel and also shuts off the engine at a stoplight, reducing the amount of CO2 emissions. And then if we go further into hybrids, we find out that there are three different architectures of hybrids, which we will dive in deeper in the future slides. Micro hybrids and mild hybrids tend to overlap. Micro hybrids, in a micro hybrid, the electricity from the battery is not used to propel the vehicle. They are most commonly known as stop-start vehicle. One of the most popular ones is the Chevy Malibu, 2014 model year, 2015 model year, with the eco symbol on the back shown in the picture in the bottom left. This Malibu features a 2.5 liter with a heavy-duty starter and two AGM batteries, one small AGM batteries to run the accessories, which is mounted in the back of the trunk, one very large battery 950 cold cranking amps in the front to power the heavy-duty starter for the auto stop. Most engines in a micro hybrid are usually restarted by alternator, or like we said, with a heavy-duty starter in the case of that Malibu. Mild hybrids, just a small step above a micro hybrid. They're not capable of using an electric motor, but what differentiates them from a micro hybrid is these systems are usually 42 to 115 volts, just depending on the size of the generator and the battery. In the bottom right picture, we have the Ecotec with the alternator generator, which in GM world is called E-Assist. That usually runs 45 volts. Medium hybrids. In this picture, we have the Saturn Vue Greenline. It's a 2.0 liter engine with also an electric motor generator that is connected to the engine by a drive belt. This car features regenerative braking and also has an advanced nickel metal hydride battery pack to actually store the power. The power is transferred from the alternator to the batteries through an engine control module and power electronics, and otherwise called an inverter. The electric motor usually assists the engine. It cannot drive the engine. Battery voltages are about 144 to 158 volts. Full hybrids. Most are capable of using the electric motor alone to propel the vehicle. The electric motor can also assist the engine. Battery voltages are about 200 to 300 volts. In this picture we have the Cadillac Escalade Hybrid 2 mode. The reason it's called the 2 mode is this setup features two electric motors inside the transmission. One for low speed application and then one for high speed application. Now when we break into the types of the hybrids, one of the early types is the series hybrid. The engine is used for charging the high voltage battery only. There is no physical connection between the gasoline engine and the drive wheel. The electric motor is the only source of propulsion, and the electric motor is powered by a battery pack which is charged by the generator through the inverter. The generator creates AC voltage, goes to the inverter changes that from AC voltage to DC voltage to be stored inside the battery. In a parallel hybrid system, the engine and the motor generators are both connected to the drive wheels as shown in this picture. Engine is used for powering the drive wheels and charging the high voltage battery. Electric is used with the engine to help propel the vehicle. In a series parallel hybrid, this architecture setup of hybrids combine both functions of a series and a parallel design, hence the series parallel name. What makes it different from the rest is it incorporates a power split device. The power split device acts kind of like a transfer case. It makes some power from the engine goes straight to the drive wheels, and then some of it goes to the generator to charge the inverter, to charge the battery through the inverter. Engine can be used for powering the drive wheels, can be used for charging the battery. The electric motor is capable of propelling the vehicle by itself. Now to discuss some of the advantages and disadvantages. Hybrids usually have a smaller engine, higher miles per gallon compared to the base model, improved acceleration, less dependence on fossil fuels, lower emissions, federal and state incentives for driving a hybrid, kind of like the tollaways, you get to drive through the carpool lanes, generally higher resale values. Disadvantages: little highway mileage increase, sticker shock, high initial cost, needs high fuel cost to be worthwhile, higher cost to repair, extra maintenance items. Most hybrids require special tires. Switching gears, going to electric vehicles. A little history of electric vehicles. Electric vehicles date back even further than hybrid vehicles. First electric vehicle was created in 1884 by Thomas Parker in London. About 60 years later, in the late 1950s, Henny Coachworks and the National Union Electric Company built the Henny Kilowatt based on the European Renault Dauphine. General Motors, after that, built the General Motors EV1, which was the first car to be branded under the General Motors name. It was leased by General Motors Corporation from 1996 to 1999. In electric vehicles, the batteries are charged by outside power source and regenerative braking. The battery stores the electrical energy that powers the motor. The car is powered by the electric motor. Zero tailpipe emissions, but you can still get air pollution through the electricity generation. So it's basically moving the smokestack from the tailpipe to a smokestack. Electric vehicles, advantages and disadvantages. Some of the major advantages is fuel economy, zero tailpipe emissions, fuel cost savings, promotes energy security, less dependence on foreign fuel, fuel flexibility, can be charged at home or in public places. Then for city driving, it can reduce noise pollution, which means electric vehicle doesn't make as much noise during its operation as much as a internal combustion engine vehicle. Some of the disadvantages are range anxiety. People are used to being able to drive cross country with their car. In the current day, you cannot drive across the country with a electric car, and the reason for that is recharge points. Electricity isn't free, short driving range and speed, longer recharge time, then it's normally 2 seats, and not suitable for cities facing shortage of power, kind of like California. For some people, silence is a disadvantage for an electric vehicle, and also the cost of battery replacement. Now moving into the most modern technology, featuring the Chevrolet Volt, the extended range electric vehicle. So, when you're talking extended range electric vehicle, it is not a hybrid, it is not a plug-in hybrid. It is a hybrid between an electric vehicle and a hybrid vehicle. It's a next level hybrid. It was available for mass purchase in 2010 as a 2011 model year, designed to meet the needs of 75% of America's daily commuters. And it uses an advanced lithium-ion battery pack, means no gasoline, zero emissions for up to 40 miles. This 40 miles rating is how they explain the 75% of America's daily commuters, because what they expect from 75% of America is to drive around 32 miles a day. So 40 miles is within the limit of 32 miles for a daily commuter. Some of the tech specs on the Chevy Volt: it can drive around 400 miles on 6 or 7 gallons of gas. Charge time is around 6.5 hours. No external charging station required. It is a 4-seat, around 30,000 to 35,000, not including any government incentives. 0 to 60 in 8.5 seconds. A top speed of at least 100 miles per hour. And obviously regenerative braking. This diagram here shows a ghost picture of the EV, basically the frame without the body. As you can see, the lithium-ion battery is part of the frame of the car. It's a T-shaped device right in the middle. The car has an engine with a generator next to it. The transmission has a clutch pack to disengage and engage the engine depending on how you want to drive the car. If you want to drive with electric only, drive with electric and motor, or motor only. Some of the specs on the lithium-ion battery: it has a 16 kilowatt hour battery. Charging time can be improved by charging at a 240 volt outlet. It can bring the charge time to less than 3 hours, but with a 120 volt outlet, it's about 8 hours. So an overnight to get a full charge on 120 volt. Battery life expectancy is around 10 years or 150,000 miles, whichever comes. Advanced vehicle technology is changing rapidly. We just went over the past, the present, but we never know what the future holds for the vehicle of everyday customer. This picture just shows the evolution of the conventional car from being a fuel engine and transmission to being a battery, fuel, engine, motor generator, transmission, and to the most recent version of them all, the battery, motor, and transmission. Thank you.